we are going to explain about an intelligent data-driven model to secure intra-vehicle communications based on machine learning. Introduction. In electric vehicles, different sensors are attached to different parts, such as steering, brakes, engine, etc. of vehicle. These vehicles will sense the data and send result back to sensors, and sensors will act based on the response received from ECU. Sometimes some malicious users may hack the sensors and ECU communication and send the false information to ECU, and this false information causes sensors to work improperly and cause accidents. All the existing techniques using AES encryptions to have secure packet transmission between sensors and ECU, but hackers are still able to decode and encrypt the packets and hack the communication between ECU and sensors. All ECU and sensor communication with each other are using Control Area Network, which is CAN protocol. Objective. In this project, we are going to aim to address the security concerns in intra-vehicle communications by developing an intelligent data-driven model based on machine learning. The model aims to detect and prevent malicious intruder attacks that compromise the communication between sensors and electronic control units, which are ECUs, in electric vehicles. By training the models using various information algorithms such as SVM, decision tree, KNN, and proposed social spider algorithms with SVM, the system can analyze the frequency and the characteristics of incoming packets. The goal is to accurately identify anomalies or potentially harmful packets, enabling timely response and safeguarding the functionality and safety of the vehicles by minimizing the risk of accidents triggered by compromised intra-vehicle communication. Requirements of the project are hardware requirements and software requirements. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. In software requirements, we require Python IDEL of 3.7 version. Methodology, we have designed 7 modules for execution of the project. In first module, we are going to upload the dataset. In second module, here we are going to train the data to KNN algorithm and then apply the model on the test data. Similarly, we build the other three algorithms also. Next, we are going to compare the graph in sixth module. In seventh module, we will be predicting on the test data using the trained models. Execution. To execute the project, open the code folder. So this is the code folder, and this is the dataset file. This is the dataset on which we are going to predict the model. This is the main code file which contains the Python script in it. And this is the run.bat file. Instead of executing the program in command line interface, we created the bat file to execute the project. So double click on it for the execution. This is the graphical user interface of this project. With this, we are going to interact with the program. So first we need to upload the dataset. Select this dataset, open. Here the dataset is loaded. Now we are going to run KNN algorithm to detect anomaly. So click on this button to run the KNN algorithm. Here we have some different terms, which is hit rate. It refers to the true positive rate, which means classifier able to predict given record correctly as positive, and the second one as miss rate. It is the false negative rate. This means unable to predict given records correctly. Next one is false alarm rate. It is the false positive rate, which means classifying predicting negative records as positive records. Next one is correct rejection rate. It is the true negative, which means it is able to predict the given records as negative. For any classifier whose hit rate and correct rejection rate is high, it is better performing and it is efficient model. Here we got the hit rate as 91%, miss rate as 0.71, false alarm rate as 0.16, correct rejection rate is 89%. Next we are going to run decision tree algorithm. Here we got the hit rate as 92%, miss rate as 0.1, false alarm rate as 0.19, correct rejection rate as 94.7. This model is performing well because the hit rate and the correct rejection rate are very nice. Now, next we are going to run conventional SVM to detect anomaly. After running this, the hit rate for the conventional SVM algorithm is 77%. Miss rate is 0.0, false alarm rate is 0.6, correct rejection rate is 38.5. Here the performance is very low of HR hit rate and correct rejection rate, so this model is not performing well. Next, we are going to run the proposed SSO with SVM to detect anomaly. SSO social spider optimization algorithm. Just a minute. Actually, these windows are open because here we have run this algorithm. Social spider optimization algorithm. In this algorithm, dataset features vector will be considered as spiders and fitness will be calculated between all features, and features will have high similarity. This will be considered as a related and will have high fitness score, and those high fitness score features will be selected and low fitness features will be removed out. Comparison between one feature to other feature will be considered as MALE and if FEMALE spiders. After applying SSO algorithm, we will have optional features using classifier can efficiently predict anomaly from new and old records. Here the algorithm is running in the command line interface, so it is taking time. So SSO hit rate is 100, miss rate is 0.2, false alarm rate is 0.22, and correct rejection rate is 100. This model is performing very well as hit rate and correct rejection rate is very nice. Next, we are going to compare all the graphs of the algorithms. In this graph, the red line indicates the SSO, orange line indicates the decision tree, blue line indicates the KNN, SVM green line indicating the SVM. So, red line, which is SSO, this model is really performing well. Close it. Conclusion. 3 different classifiers naming decision tree, conventional SVM, and the proposed SSO with the SVM were evaluated to enhance the security of intra-vehicle communication and prevent accidents resulting from malicious intruders attacks. The decision tree algorithm showed satisfactory performance in detecting anomalies. The conventional SVM algorithm also exhibited the promising results by effectively classifying normal and attacked packets. However, SSO with SVM algorithm outperformed both classifying, achieving high accuracy rate in detecting anomalies. The performance graph illustrated the comparative performance of 3 classifiers by leveraging machine learning algorithms. It is possible to analyze incoming packets and identify potential attacks, thereby ensuring secure intra-vehicle communication and mitigating the risk of accidents caused by compromised communication channels. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.